Welcome to Future Dr. NEET Academy for the problem solving session in NEET Physics. Topic chosen today is from Chapter 5, Work, Energy and Power. And today is not problem solving session, problem questionnaire session. That is, 7 questions will be squared in this session. Now, next session only we will solve the solution for this question. Let's move to question number 1. A block of mass 10 kg moving in x direction with a constant speed of 10 meter per second is subjected to a retarding force of F equal to 0.1 x joule per meter during its travel from x equal to 20 meter to 30 meter. Its final kinetic energy will be dash. Option A, 475 joules. B option, 450 joules. C option, 275 joules. D option, 250 joules. Here you should know the relationship between work, force, kinetic energy formula. By knowing the relationship, you will solve the solution for this question. Let's move to question number 2. The potential energy of system increases if work is done by the system against a conservative force. B option, by the system against a non-conservative force. C option, upon the system by a conservative force. D option, upon the system by a non-conservative force. And that is, if you should know the relation between potential energy, work done, and also what is the meaning for conservative force and non-conservative force. By knowing this idea, you can solve this question. Let's move to question number 3. A body of mass 1 kg is thrown upward with a velocity 20 meter per second. It momentarily comes to rest after attaining a height of 18 meter. How much energy is lost due to air friction? Given 10 meter per second, that is G value given 10 meter per second square. Option A, 20 joules. B option, 30 joules. C option, 40 joules. D option, 10 joules. Here you should know the relation between energy, that velocity, height, mass. By knowing the formula, you can solve this question. Let's move to question number 4. A force F acting on an object varies with distance x as shown here. The force is in Newton and x is in meter. Work done by the force in moving the object from x equal to 0 to x equal to 6 meter is dash. That is, you should find the work done from this diagram. Option A, 4.5 joules. B option, 13.5 joules. C option, 9.0 joules. D option, 18.0 joules. That is, from the graph, what is the relation between the area of the graph and then work done with respect to force and distance? By knowing the formula, you can solve this question. Let's move to question number 5. A particle of mass m1 is moving with a velocity v1. And another particle of mass m2 is moving with a velocity v2. Both of them have the same momentum, but the different kinetic energies are E1 and E2. If m1 is greater than m2, then dash. E1 is less than E2. B option, E1 is equal to E2. C option, E1 is less than E2. Or D option, E1 is less than E2. E1 by E2, that one. So you should know the relation between the kinetic energy and momentum. By knowing the relation, you can solve this question. Let's move to question number 6. A ball of mass 2 kg and another mass 4 kg are dropped together from a 60 feet tall building. After a fall of 30 feet each towards the earth, the respective kinetic energies will be in the ratio of dash. A option, √2:1. B option, 1:4. C option, 1:2. D option, 1:√2. Here you should know the relation between kinetic energy with respect to mass and then height. By knowing the formula, you can solve this question. Let's move to last question. Two bodies with kinetic energies in the ratio 4:1 are moving with equal linear momentum. The ratio of their masses is dash. A option, 1:2. B option, 1:1. C option, 4:1. D option, 1:4. Here you should know the relation between kinetic energy and momentum. By knowing the relationship, you can find the ratio of the masses. Okay, thank you students. In next session, we will solve the solution for this question.